Hi girls, how you doing? Just a video here just to try to explain Le Chatelier to you as best I can. Now I've talked over some slides and I don't know, that might be a bit more useful to you for this topic, I'm not sure, but I thought I'd have a go at doing a video anyway. I don't know if it's going to be any use, but sure, look, we'll try and see how we get on. Okay, so we're coming towards the end of this topic, and I suppose this topic is a classic example of what we always talk about in chemistry, where there's some things you need to learn, some things you need to understand, and some things you need to practice. And this topic really does have each of those, okay? There are some things to learn, definitions, not very many, okay? So if you don't like definitions, it's a good topic to do because there aren't many of them. There's definitely practice. We've looked at that already in terms of the calculating Kc and working back to calculate concentrations of reactions at equilibrium. But then really Le Chatelier is the last part of this, and it really is something you need to understand. It's not something you can just learn off or even just practice. You need to sort of think about it and process it in your head and work on it, right? So we're going to try and do that now. What is it, first of all? So it's a concept, basically, a chemistry idea, I suppose, arose by, I'm not sure, a French chemist called Le Chatelier, surprise, surprise. And he said, basically, when a stress is applied to a system at equilibrium, a change occurs to oppose the stress and equilibrium is restored. Okay, so that's a definition you need to know. But what does it actually mean? What is a stress, for starters? Okay, well, a stress is any change in temperature, concentration, or pressure that happens in a reaction. All right, so just to demonstrate that, we're going to look at an example, and this is an example, again, I've mentioned this in the slides, so there's a bit of overkill here. I'm kind of copying myself a little bit, but I thought this might help a little bit, right? So there are a number of aspects of this that we need to look at, first of all. The first thing is the effect of temperature, concentration, pressure, or a catalyst. They're the four things, if you like, that we can change about this, okay? Now, this reaction that I've written down here is just one I've just taken. It's an example that you're supposed to be familiar with. It's called the Haber process. I've sent a link in an email to you with a video about it that you can read up on. It's very important. The production of ammonia is used in fertilizer, so it's a very important chemical process. And we're going to look at the concept, look at this reaction under each of these four categories, okay, and how it affects Kc. So I've written the equation for Kc here, okay? And the value of Kc isn't important, right, for this. But Kc is here, as you can see, right? And the products are over the reactants. Now, what Le Chatelier says is, if we add a stress, and by stress it means any one of these three things, forget about catalyst for a second, any one of these three things here, the system will try and offset that stress, all right? So, a really important thing to start with is that this information is given to you here. Now, this will always be given to you in an exam question. You're not expected to know this, that the heat of reaction for this reaction is minus 98 kilojoules. And the key figure here is this minus, because this tells you, as you know, hopefully from heat of reaction that we've done already, that this process is exothermic, all right? So let's say you're working in a factory and you want to produce as much ammonia as you can, and your boss says, go and make me as much ammonia as you can. What are you going to do? Well, one thing you can do is you can lower the temperature. Why will that affect the production of ammonia? Because of Le Chatelier. If you lower the temperature, you're basically putting a stress on the system. And by lowering the temperature, you're going to make the system offset that change. If you lower the temperature, the system will try and raise the temperature. How will it do that? By producing more of the exothermic side, by warming up effectively. And warming up is this direction in this case. Does that make sense? So it's going to produce more ammonia by more of the exothermic process if you decrease the temperature. Okay? That's the first thing. The other thing you could do in this system is that you could try to remove some of the ammonia from the container. So if you remove the ammonia, you're lowering the concentration of this right-hand side. And again, the system will try and offset that change by producing more ammonia. So literally by, let's say, every hour or so, you open the valve and you just let out the ammonia and don't let out any nitrogen or hydrogen, you will actually end up tilting it so that you end up with more ammonia produced, so it will shift it to the right-hand side. All right? The third thing you could do if you were told to produce more ammonia, first of all, we have to look at this reaction here. And in this reaction, you'll see that there's 4 moles of gas on this side. Can you see that? So there's 1 mole of nitrogen and 3 moles of hydrogen. And then there's 2 moles of ammonia on that side. So there's more moles of gas here than there is here. Okay? So if you were to increase the pressure on this system, so imagine you've got a big factory container vessel thing, right? And you increase the pressure on it. The system will try and offset that change, according to Le Chatelier, by reducing the pressure. So it will produce more of the side with fewer moles of gas, because obviously fewer moles of gas have less pressure, don't they? The less gas there is, the less pressure. So we will produce more ammonia, more of this part of the equation, by increasing the pressure, because the system will try and offset it by reducing the pressure. Does that make sense? So there's a number of things we can do. We can lower the temperature, we can raise the pressure, or we can just remove ammonia. And all of those things will lead to more ammonia being produced, according to Le Chatelier. All right, now there's an important point, which is that we just can't decrease the decrease the temperature infinitely, because obviously they'll reach a point where it no longer reacts. There's no longer enough activation energy for the particles to collide with enough energy to break bonds. So there is a happy medium there between lowering the temperature and making sure that it's not too low so that they don't even react. Same goes for pressure. We can increase and increase and increase the pressure, but eventually it becomes very expensive and dangerous to do so. So we don't necessarily increase it infinitely either. There's a happy medium. We want to increase the pressure, but not too much. Okay, so that's the basic concepts behind Le Chatelier. And I'm going to try a couple of examples of questions just to see how you get on with that. All right, hope that helps in some way.